Welcome back to session 3, children. Today we are going to see graphical solving of linear equations in two variables. Okay. In the last session I taught you how to get the linear equation for given situations. Now in this session today we are going to see the graphical method of solving it. So for solving the linear equations, simultaneous equations in two variables, that is the name that we always refer to. So we can solve by two ways. One is the graphical method and the other is the algebraic solving. Before we actually move into algebraic solving, you have to be thorough with the graphical methods of solving it. So this is nothing but little more extended portion of what you studied in the previous class. Okay. Now I have taken two equations, x minus 2y equal to 0, 3x plus 4y is equal to 20 for solving this linear equations. Okay. Now graphical solving, so immediately you have to draw the coordinate axis on your graph paper. Mark x and y axis correctly and y dash the origin O, and then x dash minus infinity, and this is x we have to do, and then we have to mark the numbers both for the x axis and also for the y axis. Now after this coordinate axes are ready, we can go for plotting the points. So in order to plot the points, we have to get some values for x and y. So what is the method? We can assign some values for x. You get the corresponding value for y for the same equation. Okay, that is the general procedure. Now for the first equation, I have assigned a value 0 for x. And you get the corresponding value of y as 0, and I have assigned some value y equal to 1, the corresponding value of x. You know that 2 into y is equal to x minus 2 equal to 0, therefore x equal to 2. Okay. Now we get the 2 points as 0, 0, 0. This is obviously the origin, and the second point is 2, 1. This is, we can give a name as A. Are you understanding? So like that I have got 2 points for the first equation. Okay. Now same thing I have to do for the other equation also. So after getting this points, so let me finish plotting it. Okay. So 0, 0. And 2, 1 is obviously from here you should get, and then from here you should get. So the value, the line is joined in this manner. Okay. Now what is the general procedure? General procedure is extend the line till the end of the paper. So the line has come out like this. And here I want to give you one simple tip. Whenever an equation is without a constant, you all know that it is passing through the origin. In the first equation also, we don't have a constant. Therefore, it is passing through the origin. That is very obvious. Are you understanding it? Oh, now let us move on to the second equation. For the second equation also, you can assign some values for x, get the corresponding value of y. Assign some value of y, we get the corresponding value for x. I have assigned a value 0. Therefore, the corresponding value 0, 4y is equal to 20. The corresponding value of y is 5. Okay. Now, in order to avoid the fractions, so what I did, here I have given a value 8. So that 8 3s are 24. Transposing to the other side, that becomes 20 minus 24. That gives an answer minus 4. 4y is equal to minus 4. Y is giving a value minus 1. For your satisfaction, we can even work out like this. 3 into 8 plus 4 into y gives you 24, 20. Now this 24 goes to the other side. You will get 4y is equal to, this is a bigger number, so minus 4. So we get y is equal to minus. You can have a small rough work, or you can even, depending upon the space, you can work out in your notebook also and get the values. Now tell me what are the points to be plotted. I have got the points to be plotted as 0, 5. We can give a name to it. Let it be C. And another point 8, minus 1. Let it be point D. So I have got 2 points C and D. Shall we plot it? Now 0, 5 is obviously a point on the y-axis. So let it be C. And then another point is 8, minus 1. So minus 1 along the y-axis, and this is the required point. And let this point be called as D. I am going to join both. So using a scale, you have to, while drawing the lines, you should be very careful that it is not overlapping with any of the other points. So you can extend on both the sides till the end of the paper. So I have extended up to this, and this also I am extending up to the end of the board. So the line is over. Okay. So like that I have plotted the 2 lines. And in order to avoid confusion, the moment a line is over, you have to write the equation. Otherwise, you will have a tendency to get confused. So this line is over. Immediately on top of it, you write the equation. Similarly, 3x minus, I will write here 3x minus plus 4y is equal to 20 is the second equation. You can draw like this. Now these 2 lines intersect at some point. Let me call this point as E. Now what are the coordinates of E? I must read. It is obviously 4 on the x side and 2 on the other side. I will mark it as 4 and 2. Now we are taking 4 and 2 as the solution for these 2 equations. That is, by drawing the 2 lines on the graph, the point of intersection, namely 4 and 2, the point E is the solution. That is, the values of E, x value 4 and y value 2 is the solution of these 2 equations. Okay. Now we can verify. How do we verify? We can substitute the values 4 and 2 in the given equations. It should satisfy. So 4 minus 2. 2 into 2, that gives you 4, equal to 0. Similarly, for the second equation, 3 into 4 plus 4 into 2, 8, that gives you 20. It is also satisfied. Therefore, 4 and 2 is the solution for these 2 equations. Here, once again, I will sum up all the points that you have learned today. First, we have to get the equations, and you have to get 2 points for both the equations. For the first equation I have got, you must have noticed why this column is left blank. Now 2 points are enough to determine a straight line. Why I have given the provision for the third point to be entered here? Just to verify whether you have drawn it correctly or whether your solutions are correct. You have to ensure. So you can put any other value, maybe 3 or 2 or -1 for any one of the variables, and get the third point also to make sure whether you are drawing it correctly. Similarly, for the other equation, I have done like this. So we can assign some values. While doing so, you may come across fractional values also. It doesn't matter. You can still work out. Okay. All the time you won't be getting the whole number values. So then after plotting, the point of intersection happens to be the solution for both the equations. Get the corresponding x and y coordinates, substitute those coordinates in the equation, and then check whether it is correct or not. If that is correct, once again you have to redo the whole process. Now after learning algebraic solving, if you solve both the equations algebraically, you will get the same values that you will be seeing in the next session. Okay. Now, there are few more points that you have to learn here. When we are solving, when we are plotting the lines on the graph sheet, there are certain things that the equations will follow. What is that? We are going to learn now. See, you have learnt how to represent the equations on the graph paper, and you have also found out what is the solution for the 2 equations. Continuing from that, always the equations, linear equations, are represented in the standard form. What is the standard form? Can anyone tell me? Can anyone tell me what is the standard form of a linear equation in 2 variables? Yes? Yes, that's very correct. That is a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 is equal to 0. This is the standard form of a linear equations in 2 variables. Okay. What are these a1, a2 and a1, a2, b1, b2 and c1, c2 are? a1 and a2 are the coefficients of x, b1, b2 are the coefficients of y, c1, c2 are the constant terms. Generally, for solving the equations algebraically, we will transpose the constant to the RHS. But that doesn't matter. This is taken to be the standard form of a linear equation. So, if you write these equations, which one we plotted just now, x minus 2y is equal to 0, 3x plus 4y is equal to 20. So, these 2 equations you have to first transpose the terms to a standard form. So, in which case you will get x minus 2y plus 0 or minus 0. So, for your satisfaction, I will take it as minus 0 itself, is equal to 0. That is in the standard form. Second equation, 3x plus 4y minus 20 equal to 0 when this 20 is taken to the other side. If this is the case, what is your a1 children? It is 1. What is your b1? Minus 2. What is your c1? 0. Minus 0 plus 0 makes no sense. We can just take it as 0. Are you understanding? Now, what is your A2? 3. What is your B2? 4. What is your C2? Minus 20. Is that clear to you? So, after bringing it to the standard form, we get the two equations which we plotted just now have become like this. X minus 2y minus 0 equal to 0. 3x plus 4y minus 20 equal to 0, in which we can take the value of A1 as 1, B1 as minus 2, C1 as 0, A2 as 3, B2 as 4, C2 as minus 20. Is that clear to all of you? Now, in that case, we have to find three ratios. What are the three ratios? A1 by A2, B1 by B2, C1 by C2. A1 by A2, B1 by B2, C1 by C2. Now, this A1, B1, C1, A2, B2, C2 are so important that will determine the nature of the equations, and hence they determine the nature of the straight lines that we have drawn. That also influences the solutions. So all the three are interrelated. The ratios A1 by A2, B1 by B2, C1 by C2 is considered to be very important because they are going to reveal some facts about the equations, about the nature of the lines that we have drawn, and also about the algebraic solutions that we are going to get after learning the methods. Is that clear to you? Now, proceeding further, in this particular equation, can you tell me what is A1 by A2? It is 1 by 3. What is B1 by B2? It is minus 2 by 4. What is C1 by C2? It is 0 by minus 20. Now, you have to compare the three values. 1 by 3, can we say that it is equal to minus 2 by 4? No, minus 2 by 4 is 0. And 0 by 20 is obviously 0. Correct? So, 1 by 3 is not equal to minus 2 by 4. Minus 2 by 4 is not equal to 0. Correct? So, this particular value is 0. Therefore, we can simply write not equal to. That is, all the three ratios are unique. All the three ratios are unique. Because they are unique, we are able to get a point of intersection. So, that is property number 1. So, in order to get the solution, what is the condition? This A1 by A2 should not be equal to B1 by B2. That should not be equal to C1 by C2. This is one condition. Now, how do we define that condition as? In the standard representation of the two equations A1 by A1x, B plus B1y plus C1 equal to 0 and A2x plus B2y plus C2 is equal to 0, the ratios A1 by A2, B1 by B2 and C1 by C2, all the three should not be equal to each other. All the three ratios should be unique. If that is the case, the equations have a solution and we give the name consistent. The equations are consistent. So, what is the implication? The implication is we are going to get a point for intersection. Are you getting it? What is the impact of these two equations? Because of this uniqueness, we will get a solution. Are you understanding? So, 3 points you have to correlate. One is if the ratios are unique. they are not equal to each other means the equations are consistent, resulting in a unique solution, which results in unique representation, which results in unique point of intersection. So you have to link all the three. Okay. Now the second condition. There may be certain cases in which the ratios A1 by A2 will be equal to B1 by B2 will be equal to C1 by C2. That may be one of the cases that you have to analyze. What will happen if all the three ratios are equal? One is the ratios A1 by A2, B1 by B2, C1 by C2. All the three are same. What will happen? The three ratios are same means, okay, the equations have infinite solutions. Infinite solutions. And we still call these equations to be consistent. Why? It has got many values. It has got many solutions. So in that sense, we call these two equations are consistent and they have many solutions. Now, I just want you to think and tell me, if you represent them on the graph sheet, how these lines will be? Can anyone tell me correctly? Think and tell me. The lines become coincident. That is, they will overlap. The lines become coincident and we get one single line for both the equations. Maybe you will get a single line like this. So that I will show in the next session. Now, next is the third situation. Third case. You may come across sometimes A1 by A2, they both are equal to B1 by B2, but that is not equal to C1 by C2. This case also we have to consider. Are you understanding? So the case 3 is what? In the standard representation of the equations, A1 by A2 and B1 by B2 are equal, but C1 by C2 is not equal. That means what? We get one more set of lines, we still get two lines, and how these lines will be? Can anyone guess and tell me? Yes, they are parallel. The lines will be parallel. Will parallel lines intersect? They won't intersect. That means, is there any solution possible? There is no solution. Then the lines are said to be parallel. The equations are inconsistent and there is no solution. So you have to relate all the three terms, all the three our judgments in the same form and evaluate. Okay. So tell me the ratios once again will repeat. There are three cases. A1 by A2 B not equal to B1 by B2 is not equal to C1 by C2 results in unique solution. That's why I didn't rub the board and kept it as it is and refer to the same equations. Second case, A1 by A2 is equal to B1 by B2 and is equal to C1 by C2. All the three ratios are same. We get coincident lines, that is, we don't have the two different lines, we will be having one single line and solutions are many. So we can conclude that there are infinite solutions, therefore consistent. The equations are consistent. In the third case, A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2, results in parallel lines. There is no solution. The equations are inconsistent. Today we verified for intersecting lines, and in the next session I'll be quoting examples for the second cases and the third case also. So we will be doing it elaborately in the next session.